Hello, welcome to Piers Rocks. As you can see, I'm sitting next to a very fine stack of Commodore floppy disk drives here. In this first episode of my Floppies Rock series, I'm going to take a look at these two 1541 Commodore disk drives. I'm going to test them. I'm going to do whatever fixings necessary to get them fully functional, ready and raring to take on the next 40 years. So, let's get over to the workbench for a closer look. Okay, so let's have a look at the first disk drive, and first thing we can see is that there's a bit of yellowing on the case. You can see a little stripe up here where obviously this bit has been in the sun and this bit hasn't. In fact, you can see that more obviously on the front because the coloured bars here are quite faded on this disk drive, but overall this drive is a little bit browner, yellower on top than it should be. Otherwise it's in pretty good physical condition. A few scuffs, a few scratches, a few marks on it, but nothing particularly worrisome on this drive. Right, I have some cotton swabs. Yeah, super clean. I mean, that transformer, that was brand new. In fact, I don't recall seeing a transformer precisely like this before. It's got the cables going in underneath it. Normally, I see the cables going in on top. No, I mean, otherwise this looks in very good condition. We're going to test the read-write head of this drive. We're going to fluke. Put it on ohms mode. And our read-write head cable. And then we're just going to test the resistance, which will be between 16 and 32 ohms for each pair. If it's so 27, that looks good. 17 looks good. 34 looks good. 28 looks good. 11 looks good. 17, right, those values all look good to me. So we'll now have a closer look at the circuit board. I have seen these bodge wires before. I think they were probably Commodore installed bodge wires. Got some nice sleeving over this resistor's legs. Some glue holding the cables down there. I'm trying to see if I see any rework at all on this. I don't believe so. And on top, well, it's a little bit dusty. We might see a capacitor go in pop. We have a capacitor across one of the legs. I'm actually seeing something just here. It looks like a leg of a component that is snapped off here. That resistor is very proud of the board as well. So everything looks slightly suspect here. but I'm not convinced that it looks problematic. So it definitely looks like a leg has snapped off a component here, and it looks like it may also have snapped off the end of that diode there, so perhaps there was a capacitor between those two as well. Hopefully that's not critical. We shall we'll plug this in, see what happens. So usual warnings apply about not working on live equipment if you don't know what you're doing and how to work safely. In this case I've checked that the metal in the case is earthed. I'm not going to stick my hands underneath here, which is where all the live electricity will be. Turn it on, see what happens, and you want to keep an eye on these lights here. These two lights here. So this is the power light. This should illuminate. It's not actually illuminating at the moment, it's just reflecting a light in the room. And then this red light here should go on briefly. We should hear the spindle motor spinning, and the light should go off and the motor should stop. That's what we expect to see if the drive is behaving normally. So let's turn it on. So that means that the CPU has booted, the spindle motor stopping and the light going off, so it suggests that this may be a working drive. Alright, here we are back with the disk drive 1, and today it's working. So I probably had something not properly connected. We will try the demo disk and see how we get on with that. Just check that error code, drive not ready. See if the drive is now ready. That all looks pretty good to me. Next we'll try it with the House of Janny disk tester. So here we have the World of Janny disk tester. We'll kick off with an alignment check. And this doesn't seem to be working very successfully. Let's see if we can figure out what's wrong. Let's try a speed test. No, it doesn't seem to be able to communicate with the disk properly. So we try basic again. Yep, we can talk to the disk drive just fine. Turn off JiffyDOS. Interesting. Works with JiffyDOS, does not work without JiffyDOS. And we're running CBM-DOS, so I don't understand why you have a problem. Set up as device 10. Well, that would be causing a problem, wouldn't it? Let's try with regular DOS. Now we know it's device 10. Try that again. What do you know? It's set up as device 10. Well, we'll have a look at the disk drive just to check that the jumper is indeed cut, and therefore it is set to device 10. Right, here we are with the first drive reassembled, and we'll just double check that it's still working. Looks good to me. On to drive 2. Right, let's take a look at this second unit. So on top, we can see it's pretty clean looking, although there's a bunch of grime between these vents here. Side looks good. This side looks good. This case really is not yellowed very much at all, which is great. Have a look underneath it. All looks fine. What do we see at the end? All looks fine, although I think that might be a replacement fuse holder in it. And then on the front, we can see that this has nice vibrant colour bars. The sticker is in very good shape, apart from a little dimple there. And there's a little scuff on the top of the unit there. So let's take this one apart. See what we can see. Oh, more dust. Quelle surprise. Even the... oh, that's some amount of... actually, there's dust on the mechanism. Often you see the mechanisms being quite clean. There's quite a lot of dust there. Obviously there's a lot of dust on the circuit board. I'm not seeing any bodges on the top of this board. A quick look at the chips for date codes. 31st week of 84, 27th of 84, 27th of 84. Can't read anything on that chip. Oh, it's printed on the left hand side. Well, I haven't got my glasses. Right, I haven't got my reading glasses on, so I can't read that. This RAM chip, it's incredibly dusty. These are these ROM chip. Now this ROM chip here has quite corroded legs. The other one has some corrosion on its legs as well. So we have some corrosion here, here. So I'm expecting there may be some problems with this RAM chip here. Sorry, ROM chip. I don't know. I don't like the look of a bunch of chips on this board. Anyway, we'll take this board off and see what's what. Let's unplug everything. While we're here, we shall do the head resistance checks. Okay. So 27, 16, 32, 27, 12. Yeah, that's good. So put that to one side. Have a look at that in a moment. Again, the transformer looks super clean in this one, although I've not seen one without the paper on it. We'll have a quick look at this fuse holder. I shall find a flat blade screwdriver to do that. Ooh, there's a bit of corrosion there. Mould, probably. Right, let's have a quick look at the fuse is good. Don't really want to touch it. Now we'll check if the heads move. Yep, they move. Not too bad. How are our heads? Heads look clean enough. Give it a quick go. Go over with some IPA. Oh, a little bit of dirt. Now we will plug in the power. See what happens. Ah, excellent. This is not booting. probably because of those RAM chips. First thing I would do is I will remove the RAM chips. I will spray some contact cleaner in the sockets, and then we'll give it another test. But I suspect these ROMs, at least one of them, is dead. In fact, pretty confident that this top ROM will be dead. If this ROM is okay, then the CPU can boot far enough to give a flash code on the red LED, and the flash code would indicate at that point if this ROM were broken. So I suspect at least this is broken. So I shall remove that, and we will spray some contact cleaner in there, and then we shall reseat it. So that side looks okay. That side looks distinctly not okay. That pin in particular looks, well, those pin 1 and pin 5 look very, very corroded. But we shall reinsert it, and we shall see what happens. Reinserted. Let's try powering it on again. Same deal. In fact, now I'm looking at it, the 6502, that leg there doesn't look very clever. So I am going to remove and reseat the 6502. Easy goesies. Let's try turning him on for the third time. Nothing doing. Okay, we shall get our oscilloscope out, and we shall see if our 6502 is actually booting. Okay, let's probe around, see what we can see. So pin 8 is voltage. Yep, 5 volts there. So ready. High. Pin 3 is the clock. Looks good. At 1 megahertz. IRQ is high. NMI is low. Okay. Sync is low. VCC we know is high. And then the address pins. So I see no activity there. No activity there. Oh, okay. I'm not at all convinced that I was making good contact. Let's go back to NMI. Oh, okay. Yeah, we got activity on the address pins. Right, so let's go to the digital pins. So 21, 22, 23, 26. 40, 39, 38, 37, 36, 35, 34. Read is, so it's reading. Not connected, not connected. 50. Set overflow. Low. That means reset. Well, perhaps I should have checked reset first, because reset is low, active low. Alright. So let's have that 6502 back out of the board, as we do not seem to have continuity from the reset pin to the rest of the board. You've seen that. Right, so now we're going to probe the 6502 signals with our oscilloscope. And we'll start with pin 2, which should be ready, which is high. Pin 3, which is phi 1, which is the incoming clock. IRQ is high. NMI is low. Let's check the reset pin. Reset pin is high. 4, 8, so the address pins. It just seems to be sitting high. Yeah, see the address lines are all high. Do we have phi 2? No, we do not have. Oh, we do. We have phi. Yeah. We have signal on set overflow. Phi not connected, not connected. Reading. And nothing on the digital pin. So I think that we probably have a dodgy ROM. So I'm going to replace that. We'll put a different ROM in there and we'll see if we get different behavior. Actually, we'll take the ROM out and we'll see what 6502 is doing. Oh, super crusty ROM. Right. Definitely not be expecting it to work without a main ROM installed. I wonder if we see any activity. So this time I'm just not getting a good connection on these pins, probably due to corrosion. There we go, we're getting activity on that address pin. That was good. So let's find a new a different ROM to install. Right, I have a replacement 901229-05 ROM to install. Jumpers should be set appropriately, and same behavior. That suggests maybe it's a 6502. Let's see if we get any different behavior. NMI pin 6 still low. Right, replacement 6502 installed. That's what I want to see. So I'm just going to put the original ROM back and see if that was okay, or if it needed to replace. I'm quite surprised that the other ROM is okay, given the state of it. The original ROM is just in a shocking state. It's good, and on it goes. The original ROM was fine. What do you know? Okay, I already know this isn't going to work. The disk drive did not detect the Commodore 64 turning on. So when we turn on the C64, the motor should spin and the red light should go on. So it's still not working. I'll just confirm that. No device present. Device not present. Okay, so it occurred to me that the reason why the disk drive will be showing the red light when the Commodore 64 is turned on is because the C64 is briefly pulling the reset line, which is on the IEC bus, low. That reset line on the IEC bus is tied to the 6502 in the 1541, so essentially it's rebooting the 5041 when the C64 is turned on.
So there's obviously a problem communicating that reset line through. Now, that doesn't explain why the C64 can't then subsequently talk to the 1541, because the reset line is not used for that. So it occurs to me that whatever ICs are on both the reset line and on other data lines for the IEC bus in 1541 must be at fault. I can see that both UA1 and UB1 are both on the reset line and data lines between the C64 and 1541. So we're going to probe with scope and have a look at what happens when we turn the C64 on. So first of all, we will probe pin 1 of UA1. That's the reset signal coming in from the C64. That's held high by the 1541, so it should briefly go low when the C64 is turned on. This isn't checking the IC operation, it's simply checking the expected thing is happening. So we see it briefly go low and then it goes high again. So pin 2, which is the output of that NOT gate, yep, we'll have a look at that. That should be high. Pin 1 is high, pin 2 is low. So this should go high briefly. It does not go high at all. Check pin 1 again. So pin 1 goes low briefly and then high, and then this pin is low, does not go high. So that suggests to me that 74LS14 UA1 is at fault. I thought I'd test the 7414s that I removed from the board from UA1 in HD Pro. That's failing. Says output pin 6 is giving the wrong output. I can't actually immediately find UA1 pins 5 and 6 on the schematic, and therefore I can't see why that would be causing a problem. In any case, I'll remove that and put a cross on it. That does seem to be faulty. And I shall take another 7414 from my stock and test that one. That one's testing fine. So I will insert that back in the 1541 board, hook it back up, and we can see if the 1541 works. Right, the driver's back together, hooked back up. Let's test it out. Well, that's a good sign. We saw the red light come on and the motor spin when we turned on the C64. We're using JiffyDOS. Check we've got a drive. Thinks we still don't have a drive. Try regular DOS. Nope, still not showing up. So, looks like we've got another failure somewhere. Back to the schematic. Right, I've removed UB1, which is an LS06. We'll give it a test. I'm probably using a standard one. Well, suggest it's in bad shape. Let's get another 7406. Right, I finally tracked down my problem with the second disk drive. I had lifted a trace when I replaced UA1, and one of the tracks was no longer connected. Specifically, I think it was pin 5 of the IEC port. Yeah, pin 5 was no longer making contact to UB1 and UA1. UB1 UA1 were connected together, but the serial data I/O line was no longer connected. And I guess the serial data I/O line is required for
data communication between the computer and the disk drive. Who knew? So, just to prove it works, there we go, we have connectivity. So now we're going to test this disk drive, and the first test I'll do is I'll put in my test disk and do a dir. Well, that doesn't sound very healthy, does it? Well, I think that's quite enough of that. Yes, you might well flash errors, because you're not in a good state at all, are you? Okay, let me put one of my scratch disks in, and we'll see if it can do any better with the scratch disk. No, that sounds about the same to me. We'll put the disk checker in, and we'll do a speed check. Okay, so it can obviously read something if it's able to do a speed test, and obviously the speed's looking pretty good. So next we shall do an alignment check. I'm not seeing the disk head move at all, and that's probably the problem with doing a DIR, because it needs to read track 18 to do a DIR. So maybe I've not even freed the heads on this disk drive, I don't remember. So we'll cancel out of this, we'll turn the drive off, and we'll try and free the heads. So it occurred to me that I could use this diagnostics tool to exercise the head using the head exerciser. So I can move it around using F1 and F3. And it is doing precisely bugger all. I see it moving. Bump to track 1, F2. Not doing anything. Okay, well, the head didn't move. Right, well, yeah, I don't think that's working. So I had a look at the physical mechanism, and it looks fine. So either there's a problem with the circuitry driving the stepper motor, or the stepper motor itself has gone bad. I'm going to work on the assumption for now that the circuitry is at fault. And in fact, I'm going to test the 7406 inverter that sits between the motor driver chip and the connection to the drive, because it looks the same as the faulty 7406 that I pulled out of the reset circuit on this drive and replaced earlier on. Some of the legs are a little bit discoloured on this 7406, like the previous 7406. So I'm going to power on the drive, power on the C64. C64 is out of shot, and I'm going to exercise the drive. I'll run the alignment test, and I will test the 7406 chip inputs, and then check we have the right outputs associated with that.
5 is low and 6 is low. Yeah, this looks very dubious, this 7406. I'm going to pull it out and test it externally and replace it if it's showing dodgy. Okay, let's test this 7406. Okay, let's try replacement. Okay, that one's good. Test it again, yeah, that one's good. Right, 7406 replaced with a tested good one. Well, that's a good sign. We successfully read the disk. So we had another failed inverter chip. I'm just going to reset up the camera and then we'll do some proper testing of this drive while it's still in pieces. Okay, hopefully you can see everything now. We'll retest the DIR, preferably with the drive door closed. Just going to reset the disk. Alright, drive reset. There we go, that works. Now we'll boot up the Diags cartridge and run some of the diagnostics tests. I've got a scratch disk in here already. Right, speed test. Yeah, pretty close. I can't remember if we did a speed test on this drive already, but showing under 1% variance. Reboot, right. Let's just try the head exerciser, given that's what we were having problems with. F2, bump to track 1. Yeah, that'll look good to me. Sounded as it should do. Seek to track 18. Yeah, looks good. Track 35. Yeah, all looks good. Right, that should be both disk drives working now. As a last step, I like to see if a tested and fixed disk drive can load a copy of Arkanoid II. This is a remastered original with copy protection, VMAX v3 copy protection, and it gives the drive a good workout. It really has to be on top form to be able to load this game. I may do a video at some point about how you actually create a copy of this, because there's some challenges involved in remastering the original version of Arkanoid II and other similarly copy protected games. Anyway, for now, let's check that Arkanoid II loads on both of these disk drives. On a working disk drive, this should take 37-38 seconds. So I'll put a timer up in the corner of the screen so you can see how long it takes, and I'll speed up the footage of the disk drive actually loading the game. So as you can see, both of these drives loaded Arkanoid II perfectly well. The symptoms that you'll see if it fails to load either are it gets stuck on the original VMAX copy protection screen. It should only sit on that for a couple of seconds if it's working. Or right at the end of the loading sequence, when the screen goes black before this screen appears, then you will just notice the disk drive will just continue the last sequence over and over again. Every few seconds it will move the heads, back, it would do a read cycle across a number of heads, it would pause, and then it would do it again. The red light will stay on, the game will never load. Sometimes it will run that sequence a few times and it will actually load. Occasionally, a perfectly good disk drive will fail to load the game. You turn the computer off, you turn it on again and load, and it will actually load the disk drive. So it's, as I said, it's a pretty good workout for the disk drives, this particular game and its copy protection. But as we can see, both of these disk drives now seem to be working really well. Right, well I hope you enjoyed me fixing these disk drives as much as I enjoyed fixing them. Just to recap what was wrong with them, this first disk drive, there was nothing wrong with it at all once I figured out that someone had cut the jumper and set it to device 10. Once I resoldered that jumper and set it to device 8, it worked perfectly fine. The second disk drive was definitely more of a challenge for me. First of all, we had a bad 6502 processor where the NMI pin was permanently pulled low, and actually that pin looks quite corroded. Then we had two bad 7406 inverter ICs. Again, these both were failed and have quite corroded looking legs. And then also a bad 7414 logic chip, I think it was. Don't have my glasses on, can't check the part number on it. Anyway, both disk drives now working flawlessly, and hopefully they'll continue to last another 40 years and my children can inherit them. Now, you can see, while I've been fixing these two disk drives, this stack of disk drives has been breeding, and I really need to get onto these disk drives, testing them and fixing them as necessary. Next time around, we're going to take a look at this 2031 disk drive. This is an IEEE 488 disk drive designed to work with the Commodore PET, whereas the 1541s are an IEC. Use the IEC bus to talk to the Commodore 64, VIC-20, and so on. Now, I'm not actually going to use the Commodore PET to talk to this 2031 next time. I'm going to explore another couple of options for driving this particular disk drive. So, if that sounds interesting, or you want to see me tackle the rest of this stack of disk drives, then please subscribe to the channel. Till next time, rock on.